Hi, my name is Amanda Herman, and this is going to be my presentation for organic chemistry. So I got reaction number 4, and so it just says explain the reaction shown below, include the following pieces in your explanation. So identify the electrophile and the necrophile, which, by the way, if I pronounce these names wrong, I'm sorry. So the electrophil is the H+, so it's going to be right there in the drawing. And then the nucleophil is going to be CH3OH. So that's right there in the drawing. So the electrophilic, so really quick to define it. So electrophil is like an electrophilic substance, so like an electron accepting reagent. And then the nucleophil is a chemical species that forms a bond with electrophils by donating an electron pair. So the H is the one that's accepting the reagent, and the CH3OH is the one donating the electron pair. So B says, draw a curved arrow mechanism for this reaction. And so here's my curved arrow mechanism. So we see that the oxygen is donating to the H and the hydrogen. And then from there that we see that the mechanism goes from the hydrogen to the oxygen plus on there. And then following the workup, we continue. And the O is donating to the carbon right there. And then going down, again, the carbon is donating to the oxygen, and then it forms this right there. So I'll kind of explain it. So here, the H acts as an electrophil and takes the lone pair of the electrons from the O atom. And then as the OH group is below the plane of the ring, thus to reduce the steric interference towards the incoming nucleophil, CH3OH, where the lone pair from O is, donates to the carbon cation, and then CH3OH attacks attacks from the above the ring, the plane of the ring. So I guess like to explain a little bit better. So the H attacks as the electrophil and takes the lone pair of electrons from the O atom. And then the epicide, I believe is what it's called, it breaks in such a way that 3 carbocation is formed, and they're stable in nature. And then like I said before, as the OH group is below the plane of the ring, thus is to reduce the steric interference towards the incoming nucleophil CH3OH, where the lone pair from the O is donated to the carbocation, therefore CH3 attacks from the above plane of the ring. So like I explained kind of in my structure, there it is. Okay, so then the next question is explain the electron flow. Kind of already explained that. Okay, next one. Okay. So indicate any geochemical or stereochemical preferences. So right here, so there's that. So here, stable carbocation is formed, and there is a possibility for a R diastereomer. Sorry, I know I'm mispronouncing it. Diastereomer, because of the S1 or SN1 reaction. So you see that oxygen is donating to the carbon right there, and then the hydrogen is donating to the carbon as well. And so that's the intermediate, and then hydrogen plus is added to it, and this is where it becomes the diastereomer. And so OH is on one form, OH is on another one, and then you see that it switches on OC3 or OCH3, and then CH3 as well. They just switch forms. So there's that. Kind of hard. So yeah, that's basically my explanation of it. So I guess to explain a little bit more of the electron for C. So yeah, like I said, the hydrogen, oxygen donates to hydrogen, and then the oxygen is going to be donated again to the hydrogen on the second form of electrons, and then the oxygen from CH3 to OH in the third one, where it's stable, is donated to the positive carbon, or the carbon with the positive electron on it. And then from there, here, I guess it's easier. So yeah, so hydrogen right there. And so then oxygen is going to take that electron, that positive electron, and then oxygen is going to take that positive electron again for the flow of it. And then also right here, hydrogen is going to take, or the, yeah, hydrogen is going to donate to the oxygen right there. And then you follow into this form right there. So I know I didn't explain it very well, but that's the best I got. It's kind of hard to understand. So thanks.